An asteroid spotted just last year is now under close watch by scientists, and while Earth might escape unscathed, the Moon could be facing a direct hit. Known as 2024 YR4, this space rock isn't just any ordinary asteroid. It has an unpredictable orbit that has kept astronomers on edge since its discovery. Initially, the risk of it striking Earth was estimated at just over 1%. A number that might sound small but is enough to trigger serious concern in the space science community. Its closest approach is expected on December 22, 2032, and early projections suggested a 1 in 83 chance of impact, which later crept higher to 2.3% before refined observations provided some reassurance for Earth. But the real danger lies elsewhere. The Moon, with no atmosphere to shield it, faces a growing probability of being hit, and the consequences of such a collision could ripple across space, threatening satellites, technological systems, and even altering the night sky with debris that might reach our planet. What seems like a distant cosmic event could end up posing serious challenges for our future, and scientists are racing to understand every twist and turn in 2024 YR4's path. To understand just how serious an impact on the Moon could be, it helps to compare Asteroid 2024 YR4 to historical events. The asteroid is estimated to be about 54 meters in diameter, eerily similar in size to the object that caused the infamous Tunguska explosion in Siberia in 1908. That event flattened over 2,000 square kilometers of forest, shattered windows hundreds of kilometers away, and released energy equivalent to multiple megaton bombs, all without even hitting the ground directly. Back then, the remoteness of Siberia spared humanity from massive casualties, but if an asteroid of the same size struck a modern urban area, the devastation would be catastrophic. Now picture that same explosion happening on the Moon. Unlike Earth, which has a thick atmosphere to burn up and slow incoming objects, the Moon has no such protection. Any asteroid that strikes its surface hits at full velocity, unleashing maximum energy with zero resistance. According to physicist Paul Wiegert and his team, the impact could eject around 100 million tons of lunar debris into space. Most of it would drift harmlessly, but simulations suggest that up to 10% could be flung toward Earth's vicinity. That debris would travel at high speed, creating a serious hazard for satellites, particularly those in low Earth orbit, where nearly 90% of our operational satellites reside. From GPS and weather monitoring to communications, a significant portion of modern infrastructure could be at risk, turning a lunar impact into a problem with very real consequences for Earth. The threat from lunar debris isn't just hypothetical, it's a challenge that scientists are taking very seriously. After an asteroid impact on the Moon, the most dangerous period wouldn't be at the moment of collision, but days afterward, when debris begins its rapid journey through space. Even a small fraction of that material entering Earth's atmosphere could create one of the most spectacular meteor showers ever witnessed, a dazzling display that might appear beautiful but carries a hidden danger. Satellites in low Earth orbit could be struck by high-speed fragments, leading to accelerated wear, permanent damage, or catastrophic collisions that disrupt essential services. Unlike ordinary space debris, which can often be tracked and avoided, the unpredictability and speed of lunar ejecta make it extremely difficult to mitigate. Researchers are using advanced simulations to map potential trajectories, testing thousands of possible scenarios to assess risks. Their models show that even a single miscalculated impact could have cascading effects on satellite networks, communication systems, and navigation technologies, highlighting the fragile balance between Earth and the hazards lurking just beyond our atmosphere. This looming threat underscores the importance of monitoring asteroids like 2024 YR4, not just for direct impact, but for the indirect consequences that ripple through our technologically dependent world. Scientists aren't just watching and waiting, they're preparing for every conceivable scenario, and some of their strategies sound like they're straight out of a sci-fi movie. One of the most seriously considered approaches is nuclear deflection, but not in the explosive, Hollywood-style way most imagine. Instead of blowing the asteroid to bits, which could create thousands of smaller hazards, the goal is to nudge it gently off course using momentum transfer. The concept is elegant in its simplicity, but challenging in execution. A robotic spacecraft would carry a nuclear device on a precision-guided trajectory toward the asteroid, detonating at a carefully calculated distance. The heat and radiation from the detonation would vaporize a small portion of the asteroid's surface, creating a reactive burst of gas and debris that acts like a miniature rocket, pushing the asteroid slightly, but enough to alter its path. It's precise, risky, and requires meticulous calculations, coordination, and international cooperation. This strategy isn't just theoretical. NASA has run full-scale simulations, imagining a major asteroid threat with a high probability of Earth impact. The results were sobering. Even with years of advance notice, current technology and response protocols fell short, revealing that humanity is far from ready for a real, imminent cosmic threat. The exercise underlined a critical truth. Preparation is everything, and every detail from trajectory calculations to international agreements could mean the difference between harmless deflection and disaster. The stakes are high, and the clock is ticking. Scientists aren't just watching and waiting, they're preparing for every conceivable scenario, and some of their strategies sound like they're straight out of a sci-fi movie. One of the most seriously considered approaches is nuclear deflection, but not in the explosive Hollywood-style way most imagine. Instead of blowing the asteroid to bits, which could create thousands of smaller hazards, the goal is to nudge it gently off course using momentum transfer. The concept is elegant in its simplicity, but challenging in execution. A robotic spacecraft would carry a nuclear device on a precision-guided trajectory toward the asteroid, detonating at a carefully calculated distance. The heat and radiation from the detonation would vaporize a small portion of the asteroid's surface, creating a reactive burst of gas and debris that acts like a miniature rocket, pushing the asteroid slightly, but enough to alter its path. It's precise, risky, and requires meticulous calculations, coordination, and international cooperation. This strategy isn't just theoretical. NASA has run full-scale simulations, imagining a major asteroid threat with a high probability of Earth impact. The results were sobering. Even with years of advance notice, current technology and response protocols fell short, revealing that humanity is far from ready for a real, imminent cosmic threat. The exercise underlined a critical truth. Preparation is everything, and every detail from trajectory calculations to international agreements could mean the difference between harmless deflection and disaster. The stakes are high, and the clock is ticking. While the nuclear deflection plan might grab headlines, scientists are also exploring other, less dramatic methods to protect Earth and its orbiting infrastructure. One approach focuses on early detection and continuous monitoring, leveraging an array of telescopes both on the ground and in space to track 2024 YR4 and similar objects with unprecedented precision. Every adjustment in the asteroid's orbit, no matter how slight, is logged, modeled, and simulated thousands of times to anticipate potential hazards. Researchers are particularly concerned about secondary effects, like lunar debris, that could cascade into near-Earth space, threatening satellites critical for communication, navigation, and weather monitoring. These aren't just abstract concerns. Simulations show that even a small fraction of debris reaching low Earth orbit could set off collisions, damage vital systems, and create more space junk, making future threats harder to track. International teams are coordinating continuously, sharing data and refining predictive models, because in space, milliseconds and meters can make all the difference. The overarching message is clear. Prevention isn't just about stopping a single asteroid. It's about safeguarding a fragile network of technology we depend on every day, preparing for chain reactions that extend far beyond the initial impact. In this intricate dance of physics and strategy, scientists are essentially building a cosmic early warning and defense system, one that could one day make the difference between catastrophe and safety. Simulations of 2024 YR4's potential impact reveal scenarios that are as fascinating as they are unnerving. When the asteroid strikes the moon at full speed, it wouldn't just leave a crater, it would eject massive amounts of lunar material into space, hurling chunks of rock and dust at tremendous velocities. While much of this debris would drift harmlessly into the void, certain trajectories could send fragments hurtling toward Earth's vicinity, directly threatening satellites in low Earth orbit. Nearly 90% of our active satellites orbit in this zone, including GPS networks, communication systems, and weather monitoring instruments, all critical for daily life on the planet. Even a small collision could trigger cascading effects, damaging multiple satellites at once and disrupting essential services. Researchers have run tens of thousands of simulations, and although a direct strike on Earth remains unlikely, the danger to our orbital infrastructure is significant enough to warrant serious attention. Beyond the practical implications, this scenario underscores how interconnected space hazards are with modern civilization, reminding us that even an impact hundreds of thousands of kilometers away can ripple back to our everyday lives. As scientists continue to refine their models, the focus isn't just on preventing a hit, it's on understanding the chain reaction and building strategies to protect both our planet and the delicate web of technology orbiting above it. As the potential threat of 2024 YR4 gained attention, scientists began exploring strategies to actively prevent a catastrophic collision. One of the most seriously considered approaches is the concept of asteroid deflection, a technique that might sound like science fiction, but is grounded in precise physics and advanced engineering. Rather than blowing the asteroid to pieces, which could create thousands of hazardous fragments, a controlled nudge could alter its trajectory enough to miss the moon or Earth entirely. This method, called momentum transfer, involves sending a robotic spacecraft equipped with a nuclear device on a carefully calculated path toward the asteroid. At a precise distance, the device would detonate, vaporizing a small portion of the asteroid's surface to produce a powerful jet of gas and debris, essentially acting as a miniature thruster to push it off course. The approach is delicate, requiring split-second timing, flawless calculations, and international coordination. Political, legal, and ethical considerations also play a role. Detonating a nuclear device in space is far from a trivial decision. Still, simulations suggest that if executed correctly, such a maneuver could prevent a disaster without creating a cloud of dangerous debris. NASA has already run emergency simulations with even higher risk scenarios, revealing just how urgent the need for preparedness is. In one hypothetical situation, an asteroid with a 72% chance of hitting Earth within 14 years proved impossible to stop using current technology and warning systems. That stark result serves as a sobering reminder. Even with advanced planning, humanity is still vulnerable, and developing effective planetary defense strategies is no longer optional. It's essential. The 2024 YR4 scenario has galvanized researchers worldwide to refine deflection techniques, improve early detection systems, and ensure that when the next cosmic threat appears, we will be ready to act before it's too late.